Right. Get a like immediately. That's great. Okay, right. I think I'll wait for a few more people to turn up. Oh, in fact, lights need to be changed. Hold on. Come on, webcam. I'm here. Okay, I think now that we've got some better lighting, it's about time to start. Okay, so first of all, before I start, just unrelated to code, is I have 100 subs now, like exactly 100, and I've been on 99 for like since before Christmas. So thanks to all of you. And I'd like to say, like, it's kind of cliche to say thanks to the 100th person, but thanks to all 100, in fact. Even the people who think my channel is still a music channel and are still subscribed. That's great. Thank you, everyone. It's kind of insane. 100 people, like, that's a lot. It's like a lot of people if you get them in one room. Particularly during COVID, even. Okay, so I think we should start doing some code. I thought we could make this a bit bigger. Come on, bigger. Thank you. This can be very big. Okay. So what I think we should implement today is a counts from Vim, which are really useful. So let's suppose that. So yeah, I'll just start by explaining what counts do. So suppose I'm in Vim, right? And in Vim, W moves forwards a word, okay, which is kind of useful. And the way delete works in Vim is you press D. Oops, that's F. And then delete waits for something else to say, like, oh, where should I move the cursor to delete? So I could say DW and it will delete a word. But also, if you put 3, or if you put a number in front of a command, like you say, so W is move forwards a word. Random Rust syntax highlighting, but there we go. Then you can put something in front of it. Say 3W will move forwards 3 words. And that seems kind of intuitive because you're like 3 words is kind of the way it works in English. And logically, DW, it will delete forward a word. And the same happens if you do D3W, that deletes forward 3 words. That's how it works in Vim. I can demonstrate. So 3W from here jumps to that point because that's a word, and that's a word. And then D3W also does that, which is kind of nice and intuitive. And Sapling can't do that right now. If we... Oh, so also, in case you're wondering, 3DW also works. But because it's like delete a word 3 times and delete word has the same effect. And in Sapling, this just doesn't work. I think Sapling gets confused. There we go. Come on. There we go. So if I were to say like 3, well, okay, there we go. It just says undefined command 3. Classic. So, and we can't do something like 3, oops, that's R. But we can do something like insert 3 trues because it would get confused and think that I3 is its own command, where in fact it's not. It should be I is the command, and then 3 is like a parameter, and it should wait for the next thing. Right. So this kind of ties into the whole rewriting as a state machine, which I was doing last stream, because the kind of point of that, it's a bit overkill for the very simple editor that it was to start with. But it'll probably get... hello Electron. You're up late. This must be very late for you. So where was I? Yeah, so having state like Sapling as a state machine was very, very overkill if there's only one state. But if you got to do something complicated like this, night then when you go to bed. Yeah, so now we've got some more complicated stuff. It starts becoming useful to have a state machine. So where were we? We were editor normal mode is where the magic needs to happen. Oh, also I should switch into a new branch. Check out branch counts. Okay, right. So where are we at? Oh yeah, it's here. So the state currently is just a string that's like, oh yeah, what stuff has the user typed, and that's I think that's not quite going to cut it anymore. I'm going to have to do something a bit better than that, because it kind of I guess we could still use the whole the setup we have currently, where we have parse keystroke, which takes a string of keystrokes and parses it, and if that is invalid, or if that's incomplete, then it just returns none. But this is kind of counter to the kind of state machine approach, because it kind of assumes stuff about this. So if you do an insert, like some insert before, then it automatically assumes here that the second argument to that. So this is the code that's like insert before, like insert before true. Wait, did that do what I wanted? Oh no, yeah, insert I is insert before. Duh. Okay, so it's like insert before null, and it just hard-codedly assumes that is that's a single character, which it could not be. Like, you could have too many different things to insert that they don't fit in the 26 letters, or 52 with capitals. Oh, I've got a second viewer again. You know what? I might whack a thing on Reddit to be like, hey, there's a stream going on, and then see who turns up. That might be cool. But anyway, let's do some programming. It doesn't really matter how many people are here. So where were we at? Okay, yeah. So what I thought is we may as well embrace the whole state machine thing, because if the kind of states between like normal mode, command mode, the kind of quitting state, if they're all going to be states, then we may as well implement the normal mode as a state machine, which is going to be this is going to break a lot, but you know, like a lot of the time you break things and then fix them, and the thing that you end up with is better. So where are we at? Okay, so now I think the state of that the state of normal mode should have substates. In my wait, I don't have a GIMP open. Okay, I can't scribble stuff. Hold on. Let's just. Does this work? Oh no! Oh no! Oh, it does. It does. Good on OBS. So let's just create a thing. There we go. Okay, so we have pretty much a kind of big normal mode state, and this is what Sapling appears in. When you boot up Sapling, it's in normal mode, and then if you were to press colon, then it goes into command mode, which is its own blob that we haven't implemented yet, and then vice versa. And currently Q goes to quit, like quit state. And like this is okay, but it would be kind of nice to have normal mode be multiple states as well. So we could have the state that we enter, and then from specifically this state, if we press colon from here, so if we're halfway through a command and we press colon, then we shouldn't jump to command mode. We should just assume that the colon is going to be part of whatever normal mode keystrokes we were typing. And then, oops, like this should send us back to here as well. This is probably escape or return. Should do this. And then we'll have something like have some kind of count. So if we, at the moment, if we press, I don't know, I, then Sapling goes into another state where it's like, hey, I'm waiting for another keystroke because I need another keystroke, and then we have another keystroke and we go back because we need the argument to insert. Hold on. Okay, that's fine. Nothing new has happened. So, but then, yeah, and other things like I, A, O, anything with an argument has this implicit extra state. And then we have kind of this weird loop where pressing something like X actually has no effect, right? Like obviously it has an effect to the file, but it doesn't have any effect to the state. It's just in the initial normal mode state where we're waiting for a command. So we're waiting for a command. The user presses X. That's X for delete. So we do the delete and we're still waiting for a command, right? Because the delete doesn't have any actual effect on the state machine. There's a kind of a hidden layer behind this that we can't see. But we have this has implicitly no effect on the state machine. And what we kind of want, if we're going to implement counts, we want to be able to add another cycle here. I'll just like make it come out. And if we were to say press some number here, so let's say we press 3, then this number should be added to the end of a command. And that should just be part of the count. So say 3x should delete 3 times. In fact, that's probably a bad example. We'd probably want something like 3j to move down 3 times. Maybe it's up. Is it up? No, it's down. And this should move the cursor down 3 times, rather than trying to read 3 as a command and then like reading and then reading j as a command. That's like the 3 should be part of j. So it's like move like 3 move downs. And there's something else that I kind of wanted to do. We're discussing this on GitHub about how counts should be implemented. And we came to the kind of conclusion that putting a count, let's say we have insert true, right? Hello. Hi. So if we have insert true, what does 3 insert true mean? Or so as another example, 3 insert as child array. Because if we switch back to Sapling again, and open sapling. If we insert an array as a new child, then we get this. But if we insert again as a new child, we get like another nested array, and we do it again, we get this. So the question was, should 30A, should it do that? Should it be the same as pressing OA, OA, OA? Or should it insert an array 3 times? So we're like, insert an array, and then insert another array, and insert another array. So which of those two? They're kind of both equally valid, in my opinion. But it gets a bit crazy if we try and insert true as a child 3 times, right? So we're like 3 OT. And of course, if you do OT and then try and insert true into true, well, it can't. So that just kind of doesn't really fit very well. And so we decided that something had to change. And then we came to the conclusion that inserting 3 OA should do the whole nesting thing. So we should end up with like array, 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 array. That should be the effect of 3 inserts of an array. And that was our conclusion. And then 3 insert true. Well, like for insert I, like that doesn't matter because the cursor gets moved. We're adding as siblings. So usually if inserting once is possible, then you can insert multiple times because you're sticking stuff into an array. That's kind of intuitively doesn't really matter. But you'd kind of want a case where you wanted 3 arrays. So we kind of got this whole thing. Or what else do we want? Well, we might want 3, an array, and then an array, and an array. That might be something else we want. And we came to the conclusion that this should be called O3A. So it's like insert 3 arrays rather than 3 times insert an array. Like this grammar doesn't make very much sense from an English standpoint. I'm sure there are some languages where this makes perfect sense. Like 3 inserts of an array will get this nested structure. And obviously you could do something like 3 insert 2 arrays. And I'm not super sure what this would mean, but it would mean something. I'm guessing it would mean something like we don't have space. I'm just going to stick it into the normal mode state machine. It would insert an array and then another one, and then inside the second one it would put 2 arrays. Then inside the second one of this it would put 2 arrays, and then the cursor would end up here. We're not brackets. This is vaguely readable, by the way. I'm not sure how good my very childish looking mouse handwriting is. So that was the conclusion we came to. So now we've got 2 different places in the state machine where we need a count. We've got here, which we've said before, is that putting a count in front of an entire command is valid, and it corresponds to the command happening 3 times. Or we implicitly have another count thing here, where once we've inserted, we've typed I for insert, then we're waiting for what do we insert, and then we can have a count there as well, because we could say insert 3 trues, and we don't expect the cursor to move at every step. So somehow we need to implement this structure in code. I'll just zoom out so we get a nice overview at the end before switching. IDE view time. Okay, right. So to start with, I think let's just keep state as it is, because we do kind of want a better system. Because at the moment the code can't specify. Where's action? Is it in here? It is. So at the moment, action is replace char, or it's insert child char, and this doesn't really work because well, inserting before 3 trues, well, like 3t is not a char. That doesn't make sense. What we more want is something like usize char. So like, oh, what numbers of the char are we going to implement? And in fact, there's a pull request currently open to add to stop even using chars here. So we can straight away say, oh yeah, it's some kind of intermediate type, because chars, there are loads of invalid chars, like the null byte is a char. Like, and why would anyone insert the null byte into a thing? Like, who would bind something to the null byte? It just doesn't make sense. So you'd want something like that, but that's going to be used a whole load of times. So what I think it makes more sense is to add another type here. Maybe it should be implemented in DAG, because it's kind of the DAG node storage specifying its, like, what other people can put into it, basically. So are there any other specifications? Okay, so there's errors. Let's get rid of this so it's bigger. Errors, edit result, log message, and then DAG. Okay, so there's nothing like this yet. So on some kind of structure, yeah, it should be a structure. What should this be called? Are the commands executed as a language with a parser, or just if x, y? Or if you could chain parse together. So kind of yes. They are sort of implemented. Where's its editor normal mode? There's a giant match somewhere, like case statement of like, oh yeah, here are all the possible things that could be a command. Parse keystroke. Keymap.get. Oh, okay, yes, yeah. So pretty much we take the way this is where commands are parsed at the moment. The way it works is as we type. Thanks for the great streams, by the way. Appreciate it. And the way this works is as you type characters, the normal mode structure, the structure that is the state of normal mode, has a let's find it, state. Yeah, so it just has a string buffer where it adds the characters you're typing to a string, and then continually parses the string to check it's valid. And if the string becomes valid at some point, then it goes, oh, you must have typed a command, and finishes. This is fairly nice because we want to specify, we want to be able to type the command into the corner like Vim does. Like if we delete 3a something, you can see in the corner it builds up the command as we're going, which is, you know, like logical. That's the logical thing you'd expect. And it's quite nice to check if you forget, oh, what have I typed? Well, I've typed this. And we could do something like that. Oh, and Vim clearly didn't like that. But there we go. So we'd want something like that, and that's very simple because the contents of this string is just what we're going to type in the corner. And Sapling does this as well. If we insert, then it kind of has an I here to say, oh yeah, we're waiting for something to go after this. But I think this string is, you can calculate it from just from the state of the state machine if we do implement it like that. So I think there's not much difference between them. And so we've got that thing, and then we ask, oh yeah, what's the first character of that? If it's none, then the question mark here returns immediately out of the function if there is no first character. And then if there is, well, if it's Q, then Q has no arguments. We just immediately return the result that we got quit. Otherwise, it's... hold on, let's this makes no sense. We should... Oh, no, this does make sense. It's fine. Don't worry. My brain was not working. And if it's, say, insert child, then we insert a child and then we look for the next character. So this is kind of like parsing. This is essentially parsing the string. But I think we may as well do the parsing as the user is typing. That kind of makes sense. So where were we at? We were trying... where were we? Oh yeah, we were adding a thing to DAG that is like, oh yeah, what type of stuff could be inserted? Or could we just represent everything as pairs? I think we probably could. Okay, so we could. But I think it would be better to do it at least specify a type. So we have pub struct node type or counted node. Oh, good. That makes sense. Cool. So I don't want to just say this, make this a strictly nodes with counts, because I think there is some other cool stuff you could do with like copy and paste. If you copy a load of nodes into a buffer, then it would be nice to be able to just insert them all. Be like, insert the contents of the copy buffer, right? And then it would just, bam, insert them all in one go. And I think that would be cool. So we could just call this enum insertable. Yeah, that will do. And we can have counted node usize char. For the time being, it'll be char. And this is the thing we've got right now. Hello. Oh, missing documentation. Okay. A specification of things which can be inserted into a DAG or into a syntax tree, and it wants me to implement this. Insert the node given by a certain char some number of times. Okay, it should be happy now. We'll just derive copy clone eq partial eq hash. Actually, let's not deal with these. When copy clone. What else? There's one more. A debug. There we go. That's what I wanted. Just clone and debug should be implemented for everything, in my opinion. Right. So now, instead of taking a char for all of the insertion, or things that correspond to insertion, so replacement can be kind of thought of as a deletion and then immediately afterwards an insertion. Where are we at? Perform edit. Yeah. Replace cursor. And now instead, replace. We could call this with, actually. Maybe that makes sense. And it's insertable. Oh, spicy. Okay, right. We've got cannot be child. Aha. Okay, this gets a bit spicier. Okay, let's just make a let unpacked and we match yeah, C and count, which should be the other way around. C match with. I don't like that so much, but I'll rename it later. It's probably complaining about missing match arm. Oh yeah, there we go. Insertable counted node. Count C. So this is kind of unpacking, and it's kind of, it's a little bit trivial because that's the only thing we can do right now, but you know, that's okay. Char not a node, that's okay. So the new node, we're going to have to create multiple new nodes. Yeah, we're not going to be able to do this as cleanly. We're going to have to explicitly clone the parent, I think, because at the moment, let's just switch to scribbly view. New layer. Ooh. Let's have a white canvas, blank canvas. So at the moment, replacement. The way replacement works, I've probably explained this a lot of times, but there we go. We can explain it again. Replacement, we have some kind of tree. Let's say it's only one thing deep. And this tree has 3 children. And I don't know, maybe they're, maybe it's an array that contains, I don't know, null, and then true, and then false. And then let's say the cursor's pointing to true here. And let's say we replace this with an array, then we'll how should I explain this? So edits and sapling aren't always replacements. So they replace one node somewhere in the tree with strictly one other node. And in this case, we were representing it as, oh yeah, this node gets swapped out for an array. So we kind of overwrite this pointer to not point here anymore. Instead, we point at an array. It's not quite that simple. We end up cloning this so that we still have the old one in case we go back to it. And then if this had parents, like there was something pointing down to it, then we would clone them as well and clone and clone and clone and clone until we get off the top and we end up with another root. And so this is very similar to how Git handles commits. But the issue here is that if we were to insert 3 arrays, then we're not simply replacing the cursor. We are just we're replacing one node with 3 nodes, but that's not a replacement. That's a 1 to 3 replacement, and that's not valid. So instead, we have to explicitly clone the parent instead. So we're saying, oh yeah, we replace this parent with a new parent that has like an array, has the old siblings here, and then it has our 3 things. Yeah, it's a bit of a mess, but we'll deal with it. And this is okay because we're just simply changing this to here. You can maybe have 2 arrows so that this is not a pointer. And now this is a 1-to-1 replacement, regardless of how many nodes I were to insert. Or we could implement it multiple times. So we could say like, oh yeah, so we ought to check that the parent is still valid because we could, I don't know, exceed some kind of child count limit instead. And then we'd be stuck. But let's switch back to here. What are we doing? Okay, so new node is, we do this. And what we could do is we could either wrap this entire thing in a for I in count up to count loop. Ooh, Rust is not happy. Ah, okay, there we go. So, and then we would insert okay at the end. Unit name. Oh, okay, well, I don't think this is a good idea anyway. We could do this, and then we could clone the parent, so we get a mutable thing, and then we could say, oh yeah, add things one by one, and then we'll. Actually, that might be a better idea, to be honest. Like we can check whether the thing is valid. Can we check whether the thing is valid? No, we can't actually. Hold on. Where does this? Huh. Maybe actually. So I think replace is not a good place to start actually. Because replace is kind of complicated. Insertion is much easier because we're doing an explicit insert here, and this can fail because we have the question mark. So we could just stick a loop around here. So this could be our up to count, except that we have to handle the error better because what's going on? Oh yeah, insert it. Insertable. And then we're going to do the hacky unpacking thing. Up here, count char equals match insertable. Count C. Okay. And now everything should go back to working again, except the code won't compile. But let's fix one thing at a time. And we do need to allocate the new node every time. So cloned cursor. What? Because insert child. Hold on. Why is the borrow checker not complaining? Okay. So the borrow checker is not complaining because the borrow checker doesn't run. So what do we want to do? Let's say we did insert 3 trues. Then we want to repeatedly check, is there a valid child? So this is spicy because at the moment every check is done explicitly. So if you do an insert, then it can either fail or it doesn't fail. There's no kind of middle line here, because we just inserting one thing, so we only need to do the validity check once. Whereas we could have a situation where we have something, I don't know, and it can only have 2 children, or up to 2 children, and it currently doesn't have any children, and we try to insert 3 things. Well, we kind of expect the first 2 additions to succeed and the third one to fail, which is kind of a failure and a success at the same time. So it's a success because we added 2 nodes, but it's a failure because we failed to add the third, and we're returning a result which is either success or failure, that you can't have both, which I'm not really sure of the best way of fixing that. I should probably stop the lines from wrapping. Oh, is there really no way of doing that? Okay, fine, we'll just have this. So okay, we're overrunning the lines anyway. This is harder than I expected it to be. Okay. So for the time being, we can just aggressively insert the right number of times and just ignore the fact that that might not work. Let's just do this. What does Rust have to say on the subject? Oh, okay, right. Oh wait, it's in DAG. 563. Okay, yes, because action. action can't specify. Action is specifying a single character, and this is specifying. This is wanting a count and a character, and action should just have the counts in. It's we should import from DAG. We're not importing. Here we are. Okay, insertable. So this is an insertable instead of a char. So is this. All three are insertables. Okay, we do need eq and hash, and debug got deleted somehow. Okay, we'll probably get more compiler errors. Oh, loads. Self.insert next to cursor. Oh, crikey. Okay, right. This is going to fail a ton of times. Maybe I was too hasty with doing all of these. Let's just have this be char. This also be char. And that. Okay, this is more reasonable. So action replace. Oh, does replace still want a... Okay, we can just hack it here and say insert one char. Oh, so what's this? Oh, okay. So we need to say... yeah, we need to just implement. Where's insertable? Basically, it's complaining that we can't. Where is it? 153. So it's saying we're trying to format the parameter C here, which the type inference is telling me is an insertable, and we can't do that because we're trying to format it with the standard formatter, and that doesn't work. We were expecting, because it was a char before, and chars can be printed with display, and it's now an insertable, and that doesn't work. So we need to implement display, no standard fumt display for insertable. And there's fumt. There we go. And this is, we're just going to match self. Also go over all the possibilities, which is only this, and it's some count C, and then we just write, we just mash them together. So we like say count C. Static str. Oh, should be this. Okay, so we're just saying, so let's say it's like three T's, then we just want to mash the count straight in front of the C. Oh, that, wouldn't it make sense to fail? I don't know. So I think Vim doesn't fail in the situation where you can't do one of the things. So if I'm at the end of a file and I delete a word, that's okay. Oh, actually no, because in Vim that's okay. Because yeah, actually, so I think for the time being it would make sense to fail. It certainly makes the code easier. But I would because the thing I thought was that Vim, if you were to do something like that, like move forward 3 words and there aren't 3 words to move over, then Vim still takes it and just does as many words as possible, but that's not the same because Vim's delete, it deletes over the region your cursor moved rather than anything else, rather than actually like having 3 explicit words that are things that you delete. It's just delete takes some movement and then deletes that distance, and moving off the end of a file is no movement, so that doesn't fail. So yes, I think failing it is good right now, but we need to be able to pass insertable in. What is Rust complaining about now? Okay, so we now have to somehow parse keystrokes, which I'm thinking we should probably how should we do this? So we need to parse counts as things. I think probably I'm just going to implement this as a state machine, at least to start with. So we have inner state, or let's call this parse state. Yeah, so I'm not. Yeah. So if the failure message contains a maximum, then the user can just easily. Yeah, I agree. That seems intuitive. But at the moment, Sapling just like puffs the error messages to standard error, which just gets deleted. Where is it? Yeah, it appears like here once Sapling quits, which is not ideal. But that can be changed. We could, in fact, do integer parsing on this step, or we could just do it this way. Let's do it this way, so I'm not just super decisive. So this is state, and we need parse state. Let's put all of the parsing code down here. And what does it have? Well, it has empty, which is the default, and which is like, oh yeah, we've typed nothing. And what can we do? So we have something like we've had a keystroke, so we've like typed I and we're waiting for something. So received. So single with args. This is janky, I think. This is going to get really complicated because we'll have like, oh, well, parse state could be like, it will have to be empty and it will have to be keystroke with args, and then there'll be keystroke with just a count, because you need to know like count 1. If I were to type another character, then it's different. Like explicitly typing 1 is different to just implicitly inserting once, because if we type another character, let's say I said something like I did 3, or so I did 1 W, right? So that's move forward 1 word. And if I did 1 6, 1, no, that was not good. So 1 4 W, then that's move forwards 14 words. But if you start with code, so and Martin says, if in my experience writing state machines is easier if you start with code. Yes, but I think, do we need a state machine? Because the kind of macro, let's try it. We don't lose anything. So we've got keystroke with args, and that has a keystroke. And then we have, or yeah, this could just be keystroke, and then count, which is kind of explicit count, and this has usize. And then there isn't one for if once we finish the count, we don't need a keystroke with implicit count with a thing because it just goes back. Let's derive. I think we can do clone and copy and debug for this. Ooh, interesting. Keystroke is not copy. Is there a reason for this? No. This just should be copy. Okay. Now, parse result, I think that's still okay. We don't really need this parse anymore. So we do want... So I think there should... Keystroke is not a great name for this. I think we need something like... because keystroke here, what this actually means, if we get the documentation, it says the possible keystrokes typed with the user without any parameters. Well, we might want keystrokes that have more than one parameter, which because like Vim has GG, but in NeoVim GG is implemented as an extra state. So there's the state that you enter when you type G, and then you type G again, and it does another state transition back to, oh yeah, we executed a command. So I think for the time being, keystroke is fine. It's not worth creating merge conflicts with the existing pull request, I think. Okay. Now we should have parse. Yeah, let's just implement it on parse state. Fun parse. And then we pass a parse state. And then... oh yeah, we should probably make this mutable. And although, no, I kind of don't like having state machines as mutable, like a mutable pointer to where the state is stored. That seems kind of messed up. And then key. No, we'll need more, obviously. And this returns a self. Or it returns self, like what the new it returns what the new state is, or it always returns a new state, and then a parse result optionally. Is that right? Yes, and in this case we don't need incomplete anymore if the incomplete is taken up by this option. Okay, so let's for keeping with the existing code. This is probably, oh yeah, this doesn't do anything. So we now need match self, and then if it's empty, then what we do? So we now match on the keystroke, because that's what we'll have to do. And then if the key is key, so currently, this is another thing. So currently, Sapling always assumes that the when the user's typing a command, it assumes they're always characters, which is maybe an okay assumption, but you might want to have yeah. So what the full state machine does, so they're saying mutable if clone, uh, mutable if not copy, and passing if it is copy. I used the not copiness, and so I used explicit passing and not copy as a guarantee that the person calling this has to consume the first state. So they can't like, oh yeah, keep a reference to the old state. That shouldn't be allowed. You should force the owner to move out, to move the new thing. And that got a little bit janky. We had to use like I had to use memory replace here. So the state transition function, it moves the it consumes the state, and then we have to do the kind of replacing it with an intermediate state as the thing is running. But I think that's like this is cleaner. Like we do a transition function, it consumes the old state and returns a new one. That's kind of like how I think a transition function works, and then we just reassign the state at the end. And it's fine. There are no heap allocations. I checked because intermediate state has no size. There's some stuff up here as well. Where are we at? Okay, so at the moment this assumes that key is a char. So if key is not a character, like you pressed F7 halfway through a command, then this assumes that that's not okay. So we do something like, actually, no, I think this is fine. We just say, yeah, no, the replacing is very unperfectionist, but I figured it was better. I mean, if you want, make a pull request to replace it. I'm completely fine. I don't think it's the best solution, but it works. And it was also nice because you can force, in some of the state transitions, if there is a proper state transition. So say it's in fact in this file. We can get rid of this, make a mark, and where is it? State. In this state transition, where's the transition function? Yeah, so it takes self as a boxed argument. So this is owned. You can't. No one else can have a reference to this, which means that if we actually perform a state transition, so we say we go from a proper state, like a normal mode state, into the quit state because the user typed Q, then we end up deallocating the other one implicitly. Yeah, so I had some issues with the whole like moving values. If you want to get it to work, if there's a cleaner solution than this with mutable variables, then that's probably better. The thing is that the vast majority of the code is the code for the state transitions, not for that little bit of code that calls them, because like you've got all of this stuff where we're just going to insert self at the end, and this makes a lot of sense. You pass the state in, and then it's up to the transition function to figure out which state you should be in at the end. That was kind of my logic for this. And then, for example, we can return. So I don't. Well, I mean, code can usually panic in unexpected ways. That's like it's quite difficult to avoid panicking because stuff like array indexing can panic, and even allocating can panic. So it's kind of not impossible to get rid of replacing. I think it is possible because where is it? The state machines, the state itself is stored in a box because states can have different sizes and we don't know which explicit type it is. The compiler knows. The compiler does know. The compiler was very angry about what I was trying to do without the replace. I tried to do like I thought it was possible to move out of a out of a field of a structure, and it seems like it's not. You have to you have to swap. You have to replace the thing. So then we have the invalid state. Where were we even at before this? Here, yeah. So if we're at the empty state, then we match the key. Oh wait, we need the key map as well as a thing. And missing match arm. So if it's key, we should probably just stick the key map, make key map work with all of the keys, because we want something like Control R in Vim is replace. But but if it does panic, then if we've replaced the okay, yeah, I see what you mean, because we've got the replaced, if it were to fail in some way, but I don't think you can catch panics, at least I don't know how to, so the code can't, because there's no way for the there's no explicit way for the state machine transition function to fail. It returns a tuple. Oh, that's cool. I didn't know the compiler checked for being able to panic. I didn't know it could do that. I thought it would just panic with undefined behavior, but I guess this is Rust and not C, and that's why. So I think this should now be a mapping from E. From keys. Ooh, spicy. So I think, okay, that should be fine. And now if we do this and this is tedious. There must be an easier way of doing this. So I heard that Q records something, so I can okay, yes, I see. Funnily enough, in Haskell, that is allowed. Like you can pass, you can create a variable as the output of a function, and then pass the variable that you're assigning to as a parameter of the function that creates the value. And it's just like, whoa! But it's completely okay in Haskell, because you're not actually assigning a value. You're assigning how do I get the value, and then that's completely okay. You can pass the like a variable name is just saying how do we get the value of this variable, and so you can, it's perfectly okay to have it as an argument to itself. And it's just like, what? The first time I saw it, my mind just boggled. I was like, why is this code not making an error? But apparently it's allowed. No, Haskell doesn't have move semantics, indeed. And now, okay, I should have done this with find and replace, actually. We can do quote dot quote with quote. Ooh, no, we can't do this. What we can do is we can do. Yeah, because if you move the pointer into, you copy the value into the function, then that's okay. I'm kind of, yeah, I'm not sure how I feel about Rust's just implicitly cloning things. I guess it makes sense. You want it to happen to integers, and if it can happen to integers, then, you know, it may as well happen to, yeah, the user may as well be able to specify it happening. Oh, what? Excuse me. Ah, there we go. Hold on, has that broken a load of things? I hope not. Okay. Where are we at? State, missing inner state. Ah, but all of the config stuff is back to normal. So now if we have key map, how should this work? If, yeah, we should probably do if let some keystroke equals key map. Yeah, so we look the whatever that character the user typed into keystroke, into the key map, and then keymap.get thing. It's keymap.get key. If this is a thing, then we return. Actually, hold on. I think we could do this much more smartly if we returned a result of parse result and then self as the error. So if the computation succeeds, then so we either have a self key. Ooh. Because so we want to feed the key through the key map first. Does that make sense? Maybe it doesn't. I'll keep implementing it this way, and then if it all goes haywire, then we know I did something wrong. So now this becomes match over got this dot okay or error no self question mark. And missing match arm. That's a decent error to have. In fact, yeah, so if this is if this is successful, then we do want to match over this, because we want to match the ones that have no parameters. Oh, silly. So what does keymap return? It returns a keystroke, doesn't it? So quit is, it's just simply okay parse state quit. Anyone who finds a better way of doing this is welcome. Oh, this is action redo. There must be a more elegant way of doing this. That keeps the type safety of, because we want to have the actions require having arguments, but we don't want to, like, we want to have some kind of intermediate value and the full value as different types, but yeah, because we keystroke is like one is what the keys get mapped to. Yeah, so I matching self and keymap.get. I thought about that, but keymap.get only works, like we only want to do this if we're in the empty state, because keymap is a mapping between keystrokes and what type of command it is currently, right? So it's like if it whether it's I for insert or whatever, rather than oh yeah, what type is the parameter? That the type of the parameter is defined. Well, it's just a char, right, at the moment, but that should be defined by the node type. So I don't think we should have global configuration for that. Okay, so we've got this, and then undo is also, we're just feeding this into it, undo. And then delete also has no arguments. What else have we got? Oh yeah, move cursor is also... Yeah, I don't know. I don't think nesting matching is too bad, because we're only going to, like, we're going to have more matches here. I'm going to have like parse state keystroke thing, and this won't be a match. This will be and then what we have another one is keystroke with explicit count, which has two fields, and these won't be matches. But the first one, what? Excuse me, what's the compiler? Stop fiddling with my code. Is this not valid somehow? Oh, it's the types. Okay, well, okay. How about I write the code badly, and then if it offends you enough, then you can fix it. How about that? Anyway, like I'm not super worried about writing ugly code and then fixing it later. That seems fine to me. At any rate, like I'd like to get something done by the end of the stream. So this, I actually think right now the most elegant thing to do. I still don't know the most elegant thing to do. Okay, fine. I succumb. I'm going to do the double match. Although I'm not convinced it will be it will be any cleaner. So this is keystroke. Yeah, so I don't think this is any cleaner, because we're going to have to say let we're going to match on keystroke question mark. Actually, maybe this is better, but we're still going to have to match, right? Yeah, I don't think this is decent, because we're going to have to say this is going to be some keystroke quit, right? And then that's going to go to okay quit, and then like all of these become separate statements. I'm like, I think I'd rather see a nested if than a shed load of statements like this. I guess that's just me. Maybe it's just me. Right, so what are the two things? So there's something like this. What's it complaining about? Oh, missing match arms. Well, at least the conversion from this into the other match is going to be quite straightforward, I think. So keystroke. What else have we got? Replace. Hold on, but replace. Oh yeah, replace. And then we should go into error some state, which is parse state, keystroke replace. And then what else have we got? We've got insert. All of the inserts have to be... Hold on. This is just... We can just say K for keystroke. And then we... Oops, that was DI. Just replace this with K. But this relies on us. I still don't like this because we're going to have to do another match to be like, there just doesn't seem to be a nice way of doing this. Because, ow. Oh, I have some drum music next to me, like a music stand covered in drums music, and I just bashed it with my hand. Hold on. So what we want is we need something. We need a parameterless enum to map keystrokes to, or to map what should we call this, like command or action identifiers maybe to. We also need a something. We need an intermediate state for actions with parameters, and we also need an enum or some data type with all the possible actions with their parameters, params, if needed. So I think we need these three things, and currently this is keystroke. And hold on, why are you complaining now? Oh, there's just more complaints. So what we could have like enum single or no arg action. Because fundamentally we need a way to have the arguments be we need to, for any data type with an argument, we need to have like the partial state of like, oh, we know it's going to be an insert, say, but we don't yet have the argument that's going to go into the insert constructor, because creating an insert is what is like action insert, or whichever type of insert child, right? And then we need an insertable in order to even construct this enum. And it would be nice if we could have two values for this. We could have like insert child something and just action insert child, which is the one we need. We need one without arguments. We could have option, I guess. So we could have like option insertable, but that's kind of jank, because we want to make sure that the edit functions, we want to make sure that we force the provider of the edit function to provide some value for all of the arguments. hold on. I have an interesting idea. So, what if the state, instead of having a keystroke that we're going to convert, that we're going to apply an argument to, we have, so this is inspecting insertable, basically. We have a constructor that's like, it takes, so we'd want to store box din. It's fun. What's the syntax? It's like fun insertable to action, right? Oh, this field doesn't implement copy. Okay, right. Well, that's fair. But like, so then instead of doing it this way and like storing the keystroke as an intermediate, we would store the constructor. So it would be like box.new okay. Oh no, I don't like this either. Okay, well, I can't think of a nice way to do this, so I'm just going to do an ugly way, and that we'll just have to deal with this. I think. Let's call this keystroke again. So, yeah, I think this is complete. I would need to check what are all the possible things. So insert, all of the inserts and replace are the only ones with parameters, and that leaves 5. Okay, so we have got all of the cases covered, because this is the issue, right? Like we could perfectly well construct keystroke undo in here, and the compiler wouldn't even notice, and that's like, because keystroke, the whole point of like this should probably be called expecting insertable. Yeah, so the whole point of this state is that it's like we've got some keystroke, and we're kind of, this is a keystroke that has a parameter, like it's an insertion, and we could be inserting true, false, whatever, and so we want to store that as a separate state, because the state where we're waiting for these extra things is that state. So it should be a separate state. We have empty, which is no one's started typing a command yet. The user types I. We need to go somewhere else, so we're like, oh yeah, we save the keystroke. Like maybe this is just overkill. Maybe we should just implement this as a parser and keep with our strings. Like keep pushing chars to the end of a string, and then we just know where counts can appear and where they can't. Maybe that's the best way. Except that in the end we're going to have to turn string into vec of keys, I think. Right, where's our existing thing? In fact, yes, I think this would work nicely. This would work much better, because where we've got this cast keystroke iter.next, this could just be another function which parses an insertable. So this would just be, we'd also have fun, or it would be parse insertable. this would be no, this doesn't need a key map. This just needs the keystrokes, and this is a string, and this is option insertable. And then in here, instead of doing this, let's just say it is this. Oh wait, yeah, we could just have this be impl iterator item. So we're passing an iterator. Oh, it's not autocomplete. Item is char. So we pass the iterator down, and then what's this? This is keystroke char iter. And then in here we expect, so we parse the insertable in here, and then we parse in the key C, in fact. And then we do the error match. Oh yeah, we'll just add some hacky stuff in here. Insertable dot counted node 1 for the time being. Ooh. What? Oh, yeah, it's some. And now, what's this? Finding objectionable. Oh, this is keystroke char iter. Parse iterable, but parse insertable. So after. Oh, I understand. It should go in here, and this should just be that. Right, exactly. What? Oh, and this is complaining because keystrokes is a list of keystrokes. Okay. Well, so anyway, I think this kind of recursive descent parser with the parse insertable and parse this thing, this should probably be opt because it returns an option. I think this whole stuff is just, we don't need this. So much time. Oh well, making mistakes is just the way. Keystroke.get. This should be keys. And this is a slice of key. What would a slice of a key look like? I guess it would be circle and a thing. I guess that would be a slice of a key. Cannot find a keystroke. Oh yeah, keys. Oops. Dot iter. And this is key iter. Oops. And this is first key. Ah yeah, we're now expecting keys. Oh yeah, we want copied because we want to copy the keystrokes because they are copy. Okay, so this is working fine, except that this is not, because next we're expecting a character. Maybe now is the time to just like make all of these insertables. Can we? Is there a nice way of creating a vector out of a slice? Is it just vec.from? We should have done this conversion into keystrokes much earlier, because like it was obvious that the user, like assuming that the user only types characters, like that's a fishy assumption, because they like you can hold down modifier keys to owned. Does that work? Oh, okay. Oh, to vec. Oh, wow, wow. Okay. I reckon this probably, like, I think to vec just calls to owned, or the other way around. Can we look at the source? Hack.tovec. This is great. When you look into the source code of the standard library and it's like, see the hack module. That increases my confidence in Rust, I got to admit. Oh, help. How do we edit the last file? There must be a way. I can just get back to normal mode. Anyway. So what does to owned look like? Ooh, okay, so that's in a trait implementation. I think to vec is going to be easier on the compiler and everything. So, oh yeah, all of these need to be... Oops, why I... that... Does it annoy anyone else who uses Vim, by the way, that D for delete automatically overwrites the copy-paste buffer? Am I the only person who gets annoyed by this? Because the number of times I copy things is significantly less than the number of times I delete things. And because I was thinking about this from the context of like making Sapling, and Sapling doesn't really have a concept of deleting characters. So kind of the X key is up for grabs. And I was thinking it makes more sense to have X be cut. So delete and put into the copy paste buffer, right? And okay, so I know Vim has lots of buffers, but it takes me too much brain power to learn how they work, so I just haven't yet. And at the moment, I'm just annoyed that in order to... So what I'm doing here, right, is I'm replacing... I want to replace... Wait, hold on. What have you been using to delete things? Yeah, DDP is the nice way of swapping two lines around. But yeah, so here's my thing. So I think D should be plain delete, like delete and not. It should delete but not. Wait, does backspace work? Hold on. How is like? Because so what I thought was that X should be cut and D should be delete. So if I wanted to, let's say I was wanting to replace the contents of this. Oh, okay. Yeah. So that's like, that's the Kakuon mentality, is you select and then make a delete. So if I exit Vim and then open the same thing, what is it? Editor, normal mode. If I edit the same thing in Kakuon, apart from the syntax highlighting being worse. If I were to do, say I wanted to delete this line, as you can see, moving forwards is actually selecting things, right? So I would do move forwards several words and then delete to delete, right? X apparently does something different. But the thing is, like, this is the only way you can delete something in Kakuen. Like, D for delete. Also, I thought X should be overwrite clipboard and D should be delete. Because I was also going to implement this in Sapling. So I thought, okay, so when you delete a selection, okay, I kind of assume that a lot of the times the selection you're deleting is a chunk of the syntax tree. That was my thoughts. And so you would do something like do this, and let's say you just go back to Vim because yes, but I know that's what X does in Vim. So X deletes one character, and like so let's go into Vim editor. What is it? Normal mode. So in Vim, X deletes one character. Okay, that's how X works. And the thing is that X like doesn't really. Oh, that's cool. I didn't know that XP was a thing. But yes, XP is a thing. But the thing is, in the context of Sapling, the only thing... Oh, yes, we can't compile. Git stash. So the thing is that X doesn't really have any meaning in Sapling, is what I was thinking, right? So X and delete kind of do the same thing, because in Sapling you always have a selection. So say this, like we're implicitly selecting the children as well, which is something that I've yet to add syntax highlighting for. So these should be highlighted as well, maybe grey, because they're not the thing we're selecting. We're selecting the array. But implicitly, if we were to delete the array, we can't because it's the root. But yeah, exactly, because X is kind of X is it's a free for all as far as the rebinding is concerned. So yeah. So my thoughts were that X, I wanted like a selection should be multiple nodes. Okay, so having the cursor is the same as this is how it works in Kakuen. In Kakuen, the cursor is a selection of one char. So X is not a thing in Kakuen. Let's just Kak editor normal mode. X selects a line in Kakuen, because if you want to delete something, if you want to delete the location of the cursor, you press D, and because D deletes the current selection, and in Kakuen the cursor is a selection of one character, right? Like it's the selection from here to here. That's probably really hard to see, but Kakuen thinks it's a selection of one character, and that now X and D, there's no reason to have two different things, because if you want to delete a character, then you press D, and if you want to delete something else, you make so exactly, if everything is a selection. And I thought that Sapling, like, since we're reinventing enough of the wheel already, right? We may as well reinvent more of the wheel and just like fix things that just fix some problems with Vim, right? It's like Vim is not perfect. It's good and all, and it's really useful that it's like installed everywhere. But it's still like it could definitely have things fixed and improved. And I think like Kakuen does a nice job of it. Like it still feels like Vim, but it's just a little bit like some of the weirdnesses have been fixed. But anyway, like that's an aside. So I thought that in Sapling you could have multiple cursors in inverted commas, which is that a selection, let's say I wanted to select true and false here, then I would somehow be able to have a cursor at both true and at false. And that should be kind of allowed, in my opinion. And then you could maybe have another cursor here, right? And then we would be selecting these three in my horrendously janky thing. But, and then when you cut or like copy to the buffer, it would copy everything in your selection as a block. It would copy all of the nodes under all of the cursors. And you would just enforce a rule that no cursor can be a parent of the other cursor, because that would be like weird. You could copy the internal thing and the external, and maybe that would be okay. I don't know, but I thought that it would be cool since we're selecting blocks of syntax anyway, because a lot of the time I find myself deleting things like, oh yeah, I want to delete the contents of this bracket. Then I'm like, oh yeah, or replace it even. So I'll be like, replace everything in. Oh wait, that's not how replace works. I remember now. It's C, everything in these brackets. Oh, whoops, CI bracket. But the thing is, that's just in Sapling. That would just be we select this whole chunk as a chunk, and then we replace this syntax tree element with something else. So it doesn't really matter that the line between selections and the cursor is kind of blurred, because in Sapling you select elements of the syntax tree. Like you can go like here, or you can select the root. That's like a nice example, and we can replace the root with something else. And like it doesn't really matter. We don't want to be able to select the U of true. Like deleting the U out of true makes no sense as far as JSON is concerned. So that shouldn't be possible. And so we just have replacements. And so essentially the cursor is, instead of being like the cursor being a single point in the text, as it is for text editors, instead of that, it would be the cursor is, like, it's essentially a span, right? It's a span of the input text, because it is assuming that syntax tree elements are contiguous, which is a fairly decent assumption because they have to be parsed with stack machines, and therefore they have to be contiguous. And so it kind of makes sense that, like, oh yeah, if this whole section is our cursor, then like why the heck is there a differentiation between a selection and a cursor? Because let's say we wanted to select multiple statements. Well, isn't that kind of the same as having one cursor at this statement and then another cursor at the next statement, right? That's kind of the same. And if we wanted to copy both of these, like we wanted to move them somewhere else, right? Like, which is quite common. You have some statements. Oh yeah, and you suddenly realize, oh wait, we should have done this at the end of the function, right? You would do something like this. Like obviously that's wrong in the context of the code, but that's quite a common thing. And what you could view that as is, oh yeah, we put our cursor over this syntax tree element, and then we put our other cursor over this one, so we have both of these selected. We cut both of these into the buffer with X, because X and D are like they're both up for grabs. We cut both of these to the buffer, and then we move somewhere else, so we would highlight our selection here. And then what I was thinking is we have a special character for the stuff in the copy paste buffer. So here we would say insert after null, which is like insert null after the cursor. And instead of that, if we can say A3 null, and that inserts 3 null, like by extension, what about if we insert the contents of the buffer, the copy paste buffer, after the cursor? and that would have the same effect of this, right? It would insert, we would be selecting this, and then we would insert all of the things we copied one after the other after it. So invalid code is a problem, and currently we don't, because I've just like been putting invalid code off, because Sapling can't open text files yet, because if you open text files, you're forced to confront the whole what do you do with invalid code, which is, you know, like that's a problem. Yes, yeah. So obviously, when you're working on something, the code is invalid, but there are kind of two types, at least two types of invalid, right? There's syntactically invalid, which is that the code structurally doesn't make sense. So as an example, in Rust, if I added an open bracket here, like this code no longer makes any structural sense. This is not like this code has no structure. It doesn't make sense. Whereas you can have code that structurally makes sense. So it's syntactically correct. Like the syntax is possible. You could parse it with a parser, but the code actually makes no sense. So like if I just have, I don't know, I call some bizarrely named function that doesn't exist. Okay, this is not a syntax error because the code, this looks like valid Rust code, and to something just parsing the code, it is valid. It just doesn't check that, oh wait, is not defined, however you would pronounce this function, like that is not defined anywhere, so the code doesn't make sense. But it's like it's a different level of not making sense, right? It's like there's a deeper meaning to the code. The surface meaning of how is the code structured checks out, and the lower meaning of this code is invalid doesn't make sense, right? Like the code is structurally correct but semantically invalid. Like it looks correct but has no meaning is basically the issue here. And the idea of Sapling and other structured text editors, or at least, yeah, so projectional editors, there are two types of editors where you edit syntax trees out there. Two main classes, right? There's structured, which is you edit text files, which is what Sapling is aiming to do. From the outside world, a structured text editor is just a text editor. It stores text as a buffer usually, and it kind of it gives you the impression that you're editing a syntax tree, but actually you're not. You're editing text, and the editor understands the layout of the syntax tree in your code. So it can kind of say something along the lines of, oh yeah, well, this entire block is a function, right? And the function is called main. But this is still a block of text as far as a structured text editor is concerned. There's no issue with this. And then like this is one statement, this is one statement and stuff. And then it gives you a structured text editor classically will give you options to just edit the text directly, and then it will keep parsing the syntax tree in the background to keep it up to date. Or it will additionally, you can say stuff like delete a statement or something, and that will it will go, oh yeah, hey, the selection's here. Well, a statement is this bit of text. Like the statement that you're in is this bit of text, and then it will delete it for you. And that's how structured editors typically work. So they're fundamentally editing syntax trees over text. Right? The back end format is text, whereas projectional editors are different again. They're the kind of same concept. You edit syntax trees primarily, but the back end is the syntax tree. You don't save text, you save the syntax tree onto disk. And that brings with it a whole load of really nice features. Like you can do, like you can completely remove a whole class of errors, because instead of having variable names, you just kind of like attach the IDs. So say, where is it? Arena is used here, and arena is defined up here. So these two bits of text are, or bits of the syntax tree are intrinsically linked. They are referring to the same thing, or more precisely, this one is referring to that one. Okay, and does arena appear again? Yeah, so these two both refer to this one. And in projectional editors, it's quite common for that to be in the language, right? Like, instead of this being the text arena, it's just a pointer up to here to say, oh, whatever this variable's called. Like, this variable, it's whatever this is called, I'm also called. Like, we're the same. And then it has just really nice features. Like, if you were to rename one of them, it just automatically renames everything. There's no way of trying to do that yourself. You don't have to figure out where all the instances are. It's just like look up the pointer, change some string buffer, and then everything updates, which is very nice. Like, that's definitely what I feel the future of programming should be, or at least something like that. It's way better than editing text. But the issue is that everyone uses text. Like, that's just fundamental, is that you write some source code, you share text with people, and text is such a simple thing for computers to understand. Oh, okay. So, sorry, I understand about Unicode. Text is not simple for computers to understand, but it's not absolutely simple, but it is a hell of a lot simpler than syntax trees and this kind of pointer graphs. And it's easy to do stuff like diffing text. Like, oh yeah, what's the difference between these two files? Well, if they're text, that's really straightforward, or at least it's a closed problem, relatively closed. People have solved it. Like, Git diffing works excellently for 90% of cases. And in fact, Git is just like Git, GitHub, all of these things kind of implicitly assume that you're coding as text files, right? That makes sense. Oh, you're confused. I'm sorry, I could, like, sorry if this is super noisy. I have a microphone in front of me that you can't see. All right, what are you confused about? If you just whack up what you're confused about. I sometimes have a habit of rambling. But, like, live streams are just... The point of live streams is to ramble, and I have people who seem to like me rambling, because, like, good ideas usually start out as rambling. But anyway, so the issue with projectional editors, the fundamental issue is that they're completely incompatible with all of the existing tools. Like, the projectional editors are usually tied to the language they're editing. Like Dion is an example. Dion is I might have a link somewhere, but it's a very fancy projectional editor. It has a really nice user interface with loads of animations and stuff. But the issue is, if I wanted to contribute to a Dion project, a project written in the language, right? The language and the editor are linked, like, fundamentally, because the language is not, like, there's no kind of grammar for the language. The language is a syntax tree with some annotations and, like, pointers and stuff. And the editor is something that edits that. But the thing is, if I wanted to use Vim or Visual Studio, which is like 3/4 of developers or something ridiculous, like, VS Code has some huge mind share over developers. And so if I wanted to start a project in Dion, because I'm like, this is the future of programming, right? And I want to do a project in Dion. Let's say I boot up Dion editor, it's fine. I start working. I put my syntax trees on GitHub. Git doesn't understand syntax trees, so the diffing will be horrendous because they're just presumably binary files, or there's some kind of semantic structure or syntactic structure to them. So yeah, I've seen your thing, but I guess that's... Aha, so that's the thing. So Sapling is... yeah, so this is what people usually say when, like, someone suggests structured editing. No, that does make sense. That's what I thought as well. And what this is, like, the idea behind Sapling is actually not really my idea. Like, I've got to give credit to Stanton, who's my friend, who I would ordinarily be at uni with him, but he had the idea of this. Oh, like what Sapling is kind of his brainchild, but I started implementing it. And it's basically that actually when you're writing code with a text editor, you're inserting characters one by one, or you're like copying and pasting blocks of text. But that's not what you're thinking, right? If I no, so in Sapling you can't edit the text directly, or at least you can't right now. And the reason why I think this is okay, like Sapling will never be something to edit config files. It won't be like, oh yeah, you open SSH and you're like, oh, I'm working on a server, I need to open some config files, let's open Sapling. That's kind of, it won't really work because Sapling needs to know the structure of whatever you're editing. And some things like Markdown have minimal structure to them, and so that just doesn't make any sense. But the thing is that I figure 90% of the time, or 99 even % of the time, when programmers are coding, they're coding. It's the name is coding. It's called coding, not texting, right? Like, apart from the fact that texting is a different thing. Like you are editing code and not text, and that's quite important because the text you're editing is supposed to be very heavily structured, right? Like I could take the output of like completely random noise, interpret it as characters, and save it to a .rs file. That doesn't make it valid Rust code. Like that. Okay, that is in theory a valid text file. Like it's a valid file, but it's not valid Rust code. And therefore there's like huge swathes of the possible text files that I could possibly be editing I just don't care about. Like, they're not going to be the goal of my project, because when I'm writing code in a text editor, what I'm actually trying to do is to write text, right? Well, so I'm writing text, but I'm thinking about code. If I'm like, I don't know, where's some example? If I want to add a function call here, or, come on. If I wanted to, I don't know, add a function call round this, so I wanted to say println this, okay? Something like this. Then, okay, ignore the fact that Rust doesn't like this. It's syntactically correct. So when I want to do this, what I think about is, I think, okay, I have this function. This function is an element of the syntax tree, right? This whole section is an element of the syntax tree. And what I want to do to this element of the syntax tree is I want to wrap println around it, okay? And I'm thinking, oh yeah, so I get the result of this and I pass it into println, okay? That's what I'm thinking about. I'm not thinking about, oh, I need to edit text. I need to say, oh yeah, println exclamation mark bracket quote colon like square curly braces thing, and then I need to so I'm at this point and I need to move to the end of the line, which in Vim, okay, fair, that's one keystroke. I can just press $, and I jump to the end of the line. That's okay. And then I add the closing bracket. Okay, that was what? How many operations is that? And how long did it take me to explain? And all I actually thought about was I want to pass the result of editor.run into println. Right, that's one thought, and it took me, 10 or 20 individual actions to make that happen. Okay, obviously we're going to have to... Oh, nice. So we're going to have to specify what println is, okay, because we don't know what we're inserting around. But the idea behind Sapling is that it would be faster. What I think about is, I want to wrap this in println, and there should just be a way of doing that, because the modification of a syntax tree that corresponds to that action is quite simple. We have editor.run as a node, okay, and then there's some kind of syntax tree structure. Yeah, so exactly, and a lot of problems disappear. Like obviously, yeah. So we don't have to worry about white space. That's a nice feature, except that with auto formatters that is less of an issue anyway, because when I like, for example, for me, if I save Rust code, let's say I do something weird like this and save, then the code reformats on save, so it's less of an issue anyway. But like, why would that be a thing? Like, you don't need. It is unfortunately having Vim key bindings is not very intuitive for beginners. But it is like the what Charlie Stanton called this was trying to minimize the brain to editor gap, right? So there's some kind of gap between what I think, what like the actions that I think about and the actions that my text editor has to deal with. They're two separate things, and there's kind of they've got to be, right, because otherwise programming languages would be made up of thoughts, and no one knows how to do that yet. And so until we can actually read the mind of the programmer, there is not a lot of point doing like there's going to have to be a different way of representing the program to what you think about. But the whole point of having tools, like the reason why I prefer Vim as a text editor is not because I'm, I don't know, some kind of like what's the word, masochist who likes learning hard pieces of software. It's because when I think about coding, a lot of the things that I think about have single actions in Vim. So like, let's say I wanted to replace the contents of this set of brackets. Well, so in a traditional text editor, let's say I did this in VS Code or Nano or something like that, or Sublime Text or any text editor that is just text and it has none of Vim's fanciness, then I would either like use the arrow keys to figure out where it is, then hold down shift, then select all of this stuff. Or I would go to the mouse, which is already like seconds lost, and select the section I want to do, delete, move my hand back to the keyboard, and then and then I can get my thing, right? But Vim has like complex like command structures that can do this kind of thing for you, right? So you can do something like DA bracket, or sorry, yeah, that should have been DI bracket. So we want to delete inside brackets, and then it just happens in one go. And what I thought about was I want to delete the contents of brackets, and my thoughts translate right down to what the editor should do. Or something like, oh, I want to delete the contents of the bracket and replace it with something else. And in fact, Vim could do even better than just delete, because if I press C instead of D, C is like D for delete, except that it puts me into insert mode again after I finish. So see the contents of this bracket, and now when I type, it goes into the contents. Okay, and this is even like this is better distinctly because I think I want to I want to replace the contents of the bracket with something else. Let's say I wanted to print hello world instead. Then I would say, oh yeah, CI bracket to say, oh yeah, I'm replacing this, and then type hello world. And that's like, that seems a reasonable transformation, right? That was, I thought one thought, and then it nicely translated to what I wanted to do. And that seems to me, like, that's why Vim to me is a better text editor, because I've gone through the effort of learning all of these shortcuts. And to be fair, they compose nicely. So there aren't, like, it's not like learning hundreds and hundreds and hundreds of irrelevant and unrelated things. It's quite consistent. Like, if I wanted to move forwards a word, that's W for word. And if I want to delete a word, then that's DW for like, oh yeah, delete forward a word. So the two, like, the commands build onto each other. So all I have to do is to remember that delete, D takes some movement as its argument and then deletes that structure. So it's like, let's say I wanted to delete up to this bracket. So F is for find. So F closing bracket jumps my cursor to the closing bracket. But let's say I was here again and I wanted to just delete up to that closing bracket. Well, I can say, oh yeah, I think I want to delete up to the bracket, delete find the bracket, and it does it in one shot. And that's like an example of minimizing the brain to editor gap. Because imagine you're playing a musical instrument, right? When you're playing music, the musician is not thinking about the notes. Usually they're not thinking about, oh yeah, I need to play in, let's say I'm a I don't know, a trombone player, because that's what I play. Like, you don't think, oh, I need to play a C that is third position, that's, my arm needs to be here, right? You don't think like that. You think, I need to play a C, and then it just happens, because muscle memory, you go, oh yeah, C is here, and then muscle memory makes it do that. So your brain to instrument gap has been lowered because you just have muscle memory for doing that action. And in fact, even when you're using music, when you're playing music, you're not even thinking about the notes usually. You're thinking, oh yeah, like this is a melody and it has these notes, and music is not random. It has pattern to it, otherwise it would be impossible to listen to. And so you're thinking about the overarching patterns of the music, and then subconsciously you're splitting them down into patterns of notes, and then that's into patterns of actions that your fingers and all of the parts of your body that are involved in the instrument have to do in order to get the notes out, which will form into the music that you were thinking about. Okay, and that's quite a long-winded process, but it would be even worse if you had to actually think about all of the actions you were going to do one by one, which is fundamentally what a standard text editor does, right? It forces you to think about what you want to do. Well, so I want to replace some block of code with something else. And then that's one action in my brain. That's like one phrase of music. And then or one line of a song, right? And then I actually split that into a load of actions. Like, I need to delete, so as a different example, I want to wrap editor.run in print example. Like, that whole thing is one line of music in the analogy, and I split it into several lines. I need to insert something at the start. I need to, insert println, and I need to somehow move to the end, and then I need to write the closing bracket. And that's kind of splitting the phrase into 3 notes, say, and each note requires several actions. Like, it's println, and then I have to move the arrow keys to move all the way to the end. And this is just inefficient in my view. And Vim, Kakao, and Emacs, a lot of text editors that are like looked down on as hard to use, traditionally implement this as well. They allow the user to express their thoughts more naturally. And it's important to note that they do this at a cost. They do it at a cost of learnability, because there are more individual actions you have to learn. And there's a cost to the internal complexity of the text editor, right? If a text editor can only insert characters and move a cursor, that's very simple and easy to implement. But having a modal system of like, oh yeah, there are different modes, that makes that adds a huge amount of complexity. So that's what's the last one? The last cost is generality. I love the way this whole discussion happened, and then it turns out the optimization that we talked about ages ago doesn't work. So the code would be different. But that's interesting to know. I thought the compiler was smarter about matches, actually, because that's the whole point why the match statement was introduced into C, as opposed to... I'm pretty sure that's the whole point. The match was introduced into C was because it's more efficient than an if, because the compiler can optimize it more easily. But there we go. What were we doing anyway? Doesn't matter. I feel like the discussion was worth I feel like I've had a bit of a what's the word? I've had a bit of a revelation about what live streaming should be for, because up until now I've tried to live stream me programming, and it's very much like a load of other people watching me program. And admittedly, like, I talk about my thoughts, but I don't think that's very useful because I don't program as efficiently as I would because I have to talk about what I'm doing, and it's not exactly entertaining to watch either. Is what I'm thinking. Like obviously plenty of people are watching, and like that's impressive. Like I thank everyone who's watching me code, but I'm not really taking advantage of what live streaming is actually about, which is that I have an audience that can like give me feedback, and that's like useful if I'm coding. I think it's a bit useful, but having a discussion is just way more useful. Do people agree, disagree with that? I don't know. They'll appear in chat at some point. But so maybe what I think is that maybe I should perhaps live stream less often. Like maybe I could do the weekly coding live stream, and then if I have anything to discuss, I will do a specific like discussion live stream, maybe. Because it seems like that would be a better use of live streams as a resource. Also, that the most people turned up and stayed during the discussion. Maybe that's what I'll do. Maybe I'll just try to discuss more things in the live streams. That would be better. Maybe. Anyway, I think how... Oh, good. Okay. Because there are more things to discuss, like various options for things. Like I could just because there are other things like how should you do configuration of a program? Like, is there a nice way of doing that? Because obviously there's an existing way of doing it, which is that you have config files. Vim and Emacs have their own programming language, which is usually, in both cases, it's a complete train wreck. And that's just a nightmare, in my opinion. It doesn't help anyone to have a nightmarishly complicated programming language as your config system. Not necessarily, not even complicated. It's nightmarishly idiosyncratic. Like, has loads of bizarre quirks and stuff that just like shouldn't exist. And so I think if I was going to do that, then I would use an existing language like Python or something that everyone knows. It's quite well respected. But even that I don't like particularly, because if you do something like that, if it's an interpreted language, it basically has to be... Oh, okay, hold on. We'll have this discussion another time. Anyway, the discussion was, like, there are discussions that we could have over, like, what a good config system is, whether or not, like, how much stuff should be pluginable, that kind of things. And how like the touchy-feely stuff, like how an editor should feel when being used. So, but my voice is very tired. I forgot to bring a glass of water to the live stream, and now my voice is dead tired after 2.25 hours. How is it that long? That's insane. It doesn't feel like 2 hours. Anyway, I think I'm gonna call it a night here. I think it's been useful. Like, we haven't got a pull request done or stuff like that, but I think the discussion has been worth it. So I'm not going to continue doing the pull request. I could next time continue on the same way that we did here. But yeah, I think that's it for today. So thank you all for coming, and I hope to see you all next week. Bye.